Hi, my name is Yuecheng. It's my pleasure to present our work, IntelliTex, Fabricating Low-Cost and Washable Functional Textiles using a double coating process. In this work, we propose a low-cost and highly accessible double coating fabrication method for washable and reusable functional textiles with customized input functionalities. With our method, we hope to support designers, makers, and researchers to easily create functional textiles ready to use in everyday life. Let's talk about some related works. Textiles are everywhere, thus making them an interesting medium for supporting a wide range of functionalities, including sensing, energy generation, medical treatment, etc. In our paper, we are interested in fabrics with input functionalities, referred to as fabric inputs later. These fabric inputs are gradually revealing a huge space of applications in various domains. So how can we make these fabric inputs? There are generally three categories. First, commercial piezo-resistive fabrics can be directly used to create functional textiles because they can have resistance changes when deformed. However, off-the-shelf piezo-resistive fabrics such as Onyx can be expensive, which is around $50 per square meter. Secondly, yarn-level fabrication incorporates conductive or resistive yarns during the fabrication process with techniques such as weaving, knitting, and embroidering. However, this method can be very challenging for novice designers without relevant knowledge and skills, and often requires specialized fabrication machines that are inaccessible to designers or makers. Finally, fabric-level fabrication applies conductive materials directly to off-the-shelf fabrics. However, textiles fabricated with this method usually feature low wash durability and weak abrasion resistance. To overcome this challenge, the material science community has proposed various materials to improve the fabric's washability. However, most works incorporate a complicated material preparation process and often require professional equipment that falls beyond the realm of typical fabrication labs. We enhance existing methods by proposing a new workflow featuring easy fabrication, low cost, and high washability at the same time. Next, I will illustrate the proposed double coating fabrication workflow. Firstly, off-the-shelf textiles are coated with carbon black ink, which endows textiles with conductivity and sensing capabilities. Secondly, textiles are coated with a thin layer of polyurethane to enhance the sensing stability over wash cycles. Different coating methods, including deep coating, partially deep coating, and brush coating, can be used to apply conductivity to the entire fabric, or only to design the structural parts to realize specific functionalities. Choosing different textiles to be coated can realize diverse interesting results. With this method, we can make fabric inputs with various sensing properties by taking advantage of their piezo-resistive nature. Serving as a resistor, on the other hand, enables the coated textiles to have rich interaction properties. We showcase a comprehensive fabric input library on our website, which is denoted in the footer. Detailed mechanisms for sensing or interactive inputs can be found in the full paper. To showcase the washability, we double-coated 4 representative fabric inputs using 3 different coating methods. Over the 600-minute wash, we found although the resistance increase over the wash cycles is largely unavoidable, all fabric inputs retained good input functionalities and could still function properly. This high washability can be explained by the encapsulation effect produced by the polyurethane layer, which likely reduces carbon black shedding during the wash. We also find some gap fillers formed between fibers, which possibly decrease abrasion during the wash and further improve the resistance stability. Besides, we also spot some exposed carbon black areas, which accounts for why resistance reading can still be taken from the surface of the fabric. Based on the double coating process, we further propose an integrated workflow to use the coated fabrics to create interactive textiles. Firstly, use the erasable pen or laser marking to draw the low-fidelity design of sensing areas, output components, and circuit diagram onto the base fabric. Then, double coat the fabric using one of the 3 coating methods. Next, conductive silver fabric traces with mesh TPU backing are ironed onto the base to serve as a circuit. The mesh TPU guarantees strong adhesion, washability, and good conductive contact between layers. Then, sew metal buttons onto the base fabric for additional component connection. Finally, connect the output and processor components. Detail on these components can be found on the website in the footer. To demonstrate the potential of our proposed fabrication workflow, we present several example applications. Technical details and documentation for each application can be found on our website. The link is attached in the footer. Pressure ulcer or PU is a common skin injury caused by prolonged high pressure, excessive skin temperature, or high humidity. We developed a set of reusable fabric sensor patches that could monitor the pressure, humidity, and temperature of the PU-prone areas and report high PU risks. With our method, everyday accessories can be endowed with input functionalities. We brush-coated a glove to augment it into a band input for rehabilitation training. It could capture exercise motions and thus control game objects, such as moving a rabbit to eat carrots. Personalized exercise sequences could be tailored by customizing game maps. Firefighters can lose track of the temperature with the adrenaline rush, leading to burn injuries, and the neck is one of the most frequently burned areas. We designed a neckwear that can alert firefighters to dangerous temperatures next to the skin. Fabric inputs can also be used as interesting tangible interfaces. For example, we fabricated an interface using highly elastic fabrics. Then we demonstrated its interaction potential by using it as an input for a pinball game, serving as a realistic force simulator for spring press in the virtual settings. With IntelliTex, we hope to inspire and invite creative expressions to create functional textiles ready to use in everyday life and contribute to a sustainable future for functional textiles. That's the end of my presentation. Thank you.